This is Dr. M. Sangeeta. I'm going to discuss about logic gates in today's class. Before getting into logic gates, let us discuss about the integrated circuits. The integrated circuits, it is basically made up of gates. It is made up of gates. Now, input to this integrated circuit is digital input, and output of this digital circuit of this integrated circuit is digital output. Okay, but all real-time signals are continuous signals. So it cannot accept the continuous signal, but all your electronic product, it accepts only digital input. But real-time signals are continuous signals. Now, how to convert this continuous signal to real-time signal? How to convert this continuous signal to real-time signal? So what we will just do is that we will convert a continuous signal into an analog signal into a digital signal. Let me assume a continuous signal like this. Okay, this will be f of t versus t. To sample the signal or to make it digitize the signal, let me pass it through a simple switch. This switch, I will close it for 1 second and open it for an instant. Okay, so I will get samples only for every 1 second. I will get samples for every 1 second. So again, this is not digital signal. It is only a discrete signal. To convert it to discrete signal, what I will just do is that I will go for quantization and then I will go for input. Okay. After that, I will get a digital signal. It will be in ones and zeros. Okay. So this is how we convert a digital signal into an analog signal into a digital signal. Now, the process of at input, what we are going to do, we are going to convert an analog signal to digital signal. That is, we are going to do analog to digital conversion process. It involves sampling, quantization, and coding. Now, to sample this signal, the basic criteria that need to be followed is the highest frequency is FM and is to be the frequency that you have to choose is 2 FM. That is Nyquist criteria that we have to follow. Now, basic gates. Getting into basic gates, and or an inverter is basic gates. And or an inverter is basic gates. NAND and NOR is universal gates. Other than basic gates and universal gates, we have XOR gate and XNOR gate. Now, getting into NOT gate. If you put a variable bar over a variable, then you can call it as NOT function, or you can call it as negation. If you pass A as an input, your output will be A bar. That is, if input is 0, output is 1. If input is 1, output is 0. This is the simple truth table that is followed for NOT gate, and this is the symbol that is given for NOT gate. So, output signal from NOT gate is true only if the input signal is false. The output signal from the NOT gate is false, 0, if and only if the input signal is true. AND gate. It is, we can just imagine that it is a simple multiplication. So 0, 0, it is 0, 0, 1, it is 0, 1, 0, it is 0, and 1, 1, it is 1. I'm just, I have given a 2 input AND gate here. If it is 2 input, the combination here will be 2 power input combinations that we have to check will be 2 power n combinations. There are 2 inputs, so n will be equal to 2. n will be equal to 2. So what we have to do is that 2 power n. N here is equal to 2. So it is 2 power 4. 2 power 2, it is equal to 4. So input will have 4 combinations. Now how to represent this one in case of digital input? How to represent in terms of digital input? So I have two variable input variable A and B and one output variable Y. Okay, if it is two input variable, how to represent it in digital form? It is very easy that you can use this method. 2 power 0 and 2 power 1. 2 power 0 is 1 and 2 power 2 is 2. Okay, what is the range of this AND gate? If it is two input variable, the range is from 0 to 3. So it will be 0, 1, 2 and 3. Totally it will have 4 combination, but the range will be from 0 to 3. So in this case, 0 is 0, 0. Okay, 1. Now I'm going to check about the columns. Straight to column, put 1. There is no 2. So this represents 0, 1 represents 1. 2. Straight to 2, put 1. And there is no 1 here. So this represents 2. 3. 2 plus 1 is 3. So the binary representation for 3 is 1, 1. Okay. Now represent multiplication here 0 into 0, 0, 0 into 0 into 1, 0, 1 into 0, 0, 1 into 1 is 1. This is the truth table for AND gate. This is the truth table for AND gate. Let me switch over to PPT. Okay. So the output signal from AND gate is true if it is if and only if both the inputs are true. The output signal from an AND gate is false otherwise. Now it is the same thing. If it is low, low, the output is low. If input signal is high, high, the output is high. If the input signal is low, high, the output is low. If the input signal is high, low, the output is low. The unique output here is that output is high when all inputs are low. Next gate, OR gate. OR gate represents a simple plus. Okay, 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, 1 plus 1 is 1. So if this a simple representation here is A plus B, this is a logic symbol that is given here. Okay, 0 plus, it is 2 input, the same input combination. How many input combination will be there? That will be 4 combinations. The range will be from 0 to 3. So same binary representation for this two variable at input. So it is 0, 0, 0, 1, 1, 0, 1, 1. So 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, 1 plus 1 is 1. The output signal from an OR gate is true if either or both input signals are true. Meaning one of the input signal is 1, the output is 1. The output signal from an OR gate is false if and only if both the input signal is 0. If both the inputs are 0, then the output is 0. Okay. Simple representation here is that if it is high, high, it will be high. It will be high, low, then it will be high. If it is low, high, then it will be high. If it is low, low, then it will be low. Okay. So basic gates are over. Getting into universal gates. the basic, the concept that lies behind why it is called universal gate, because you can design any gate, using this universal gates, that is NAND gate and NOR gate. NAND gate accepts two input signal. If both are 1, the output is 0. Otherwise, the output is 1. The basic Boolean expression is A into B, the whole bar. That is the Boolean expression for NAND gate. So, AND gate with negation is called NAND gate. AND gate with its negation is called, negation is that a small bubble here, NOT gate. This bubble represents NOT gate. If you separate this AND function and this bubble, it will be AND gate and NOT gate. So this will be, the truth table will be, let me calculate it for NAND gate so you can understand it for NOR gate. NAND gate. NAND gate is that you have two input NAND gate and a simple NOT gate. This is NAND gate. Okay. What is the input combination for AND gate? Already we have derived it here. Okay. AND gate 0, 0, it is 0, 0, 1, it is 0, 1, 0, it is 0, 1, 1, it is 1. Okay. So, let me take it as output of this NAND gate. This output as Y. A, B, B, and this output is Y. And this output as X. This output already I have calculated. AND gate. If I'm going to feed it as an input to the NOT gate, then the output will be, output of X will be 1, 1, 1, 0, because it is a NOT gate. 0, it will be 1, 0, it will be 1, 0, it will be 1, 1, it will be 0. Okay. So 1, 1, 1 and 0 is the output of, NAND gate. See, 1, 1 and 1, 0, this is the output of NAND gate. Now, simple. Now tell me, if it is low, low, we have seen basic gates and we have seen the basic functionalities of gates. Now tell me, if it is low, low, what will be the output? Yes, you are correct. It is high. Because any one input is low, the output is high. Next, low, high. What is the output? High. Because any one input is high, if one input is low, the output is high. Yes. High, high. What is the output now? Yes, it is low. Next. High, low. What is the output now? Yes, very good. It is high. So, if any one input is low, the output is high. That is the unique output. NOR gate. NOR gate accepts two input signal. If both input signal are 0, the output is 1. Otherwise, the output is 0. Similar to that of NAND gate, it is OR gate with negation. It is called NOR gate. It is A plus B the whole bar. It is called NOR gate. So A OR, and that output, if it is negated, then it will be NOR gate. If both the inputs are 0, then the output is 1. For other conditions, it is 0 otherwise. Okay, that is NOR gate. Only if both the inputs are 0, it is 1. If it is 0, 0, what will be the output? Yes, it is high. Good. Low, high, what is the output? It is low. Yes, very good. High, low, what is the output? It is low. Yes, very good. High, high, it is low. Yes, very good. So, if the output is high, only the inputs are low. NOR gate, XOR gate. A and B is XORed with X. Sorry, A is XORed with B and your output is X. A XOR B is assigned to X. This is the Boolean expression for XOR gate. If there are different inputs, the output is 1. If there are different inputs, the output is 1. Okay, the same input, the output is 0. 0, 1, it is 1. 1, 0, it is 1. The same input, 0, 0, it is 0. 1, 1, it is 0. Okay, this is a simple logic that we can imagine. Different input. Now tell me, low, low, what will be the output? Yes, it is low. Low, high, what will be the output? It is different input. So the output is high. Yes. High, high, what is the output? It is low. Yes, very good. High, low, what is the output? It is high. Yes, very good. Getting into XNOR gate. XOR gate with negation, it is called XNOR gate. So, there are 2 inputs. So, you will have 4 combinations. 4 input combinations. The range will be from 0 to 3. A XOR B, the whole bar will be your XNOR gate. So, if it is same input, the output is 1. If it is different input, the output is 0. 0, 0, it is 1. 1, 1, it is 1. For all other combination, it is 0. Okay. So, now tell me the answer for this one. Low, low, what will be the output? Yes, it is very good, high. For low, high, yes, it is 0. For high, high, yes, it is high. For high, low, it is low. Yes, very good, very good. Review of gate processing and NOT gate. We have seen NOT gate, AND gate, OR gate, XOR gate, XNOR gate, and NAND gate and NOR gate. NOT gate inverts single input. AND gate produces 1 if both the input values are 1. OR gate produces 0 if both the input values are 0. XOR gate produces 0 if input values are same. XNOR gate produces 0 if the input values are different. NAND gate produces 0 if both inputs are 1. NOR gate produces 1 if both inputs are 0. Thank you. Thank you all.